Hey guys, so this is help with week number 2 homework. So week number 2 homework. And so the IXL topic for this first screen here is ELJ. Which is identifying functions. So being able to tell if something's a function or not. It's pretty straightforward. If you look at this first example, it's from a table, and really what you're doing is checking for repeated x's. It's really all you're looking at. So if you look at the x's that you have up there, you have 16 and 12 and 15 and 12, right? So the problem is that this x repeats. And then if you look at the table, basically what it's saying, if the machine is here, you put in a 12, but then you're getting back a 10 and also a 16. So this is not a function because it has one input and two outputs, which really just anything more than one is a problem. All right, so this is not a function. If I'm looking at a graph, I'm looking for the same idea. If you look at what you have up there with those points, all of these points have their own individual x. So if I'm here starting at 0 and I'm trying to get to these points, to get to x on the first point, I have to go to 1, 2, 3, 4, 5, 6, 7. Whereas this point's on 8, and this point's on 9, and this point's on 10. But the idea is that you would have 7, 8, 9, 10 for your inputs for x, but they're all unique. So there are no repeated x's. And the way that we can see that more visually is to do something called a vertical line test. Which, let's see if I can annotate on here on recording. Nope, doesn't look like it. Well, anyway, the idea is though, is if you draw a vertical line through these, each vertical line will only go through one point, which means it passes the vertical line test, so it is a function. Checking x's, 13 sevens, 16 7. Problem here with the sevens, that is not a function. No repeated x's. 5, 7, 5, definitely no. 9, 11, 18, they're all unique. So really that's all you're checking. Here's a good example of a graph where 2 points stack on top of each other. So this is what I was talking about. If you draw a vertical line through those 2 points, you're going to end up going obviously through 2 points. So this is not a function. It fails the vertical line test. On my paper, it can't cross more than 1 point. Okay, so I think that's pretty good for this topic. I think you have enough information then to be able to answer these. See, I'm already all the way up to 60. Unique x's, yes. The idea, okay, so then once you get to 64, now you're going through and you're deciding which one's a function. So again, you're just looking for repeated x's. This has repeated x's, so it's not. Repeated x's. Ooh, no repeated x's. Let's double check. Here is a repeated x for 18, so it must be this one. Repeated x's, repeated x's. This is not. And this one has a whole bunch of zeros. So hopefully that seems straightforward. If we move on to the other topic for identifying functions, that's with the graphs that are continuously connected, the points are connected. So this is IXL topic AEB. And so this whole thing is with graphs. So the whole thing, you're doing the vertical line test. So really that means that you're checking to see, does the graph fold over onto itself, basically? Is there a spot where I could draw one line straight up and down, a vertical line, where it would cross twice? And yes, obviously here I could draw one. There's like an infinitely a huge amount of places I could do that. So this is not a function because it folds over back onto itself. So let's collect a few ideas of shapes. So the first one we said was not a function. Look something like that. Straight lines, no place I can put a vertical line where it crosses more than one. So this is a function. This one curves, but it still is not, there's no place on here where if I put a vertical line, it would cross it twice. It doesn't fold over onto itself. So it is a function. But this one is not. Any kind of circular or oval shape is going to be a no, because it's definitely going to cross back onto itself. Line, good. Uh-oh, oval shape. So which one of these is a function? So this oval shape is not. This straight line looks pretty good. This one folds back onto itself, right? So same as this first one we talked about. And then this one is a curved version of that, but still that same idea where it's going to curve back onto itself. So the only one that's a function is that one. Which one's a function? So oval, circle, this sideways U shape, but this is okay. So these are pretty straightforward too. Curves back onto itself, straight line, curves back onto itself right here. So that's another one I can put in here. All right, so I'll let you handle this one. I think we have enough information, but the idea is if it curves back onto itself, then there's definitely going to be spots where you could draw a vertical line and have it cross more than one. All right, moving on. Evaluate a linear function. So this is a lot like filling in a table or something like that when you were in 7th grade. So you probably have done this before. IXL Topic LNV. So y equals w minus 8. And it says find the value of y when w equals 9. So hopefully you feel pretty comfortable with the idea that this means to plug that in there so that you end up with 9 minus 8, which is 1. So these are pretty straightforward PEMDAS kinds of problems that it's evaluating. D equals k minus 1. And since k is 2, I'm going to plug in 2 minus 1, which gives me 1. S equals q minus 5, and q is going to be 6. So 6 minus 5 equals 1 again. That's crazy. S equals n plus 10. N equals 7. So this is 7 plus 10 equals 1. Okay, 17. So hopefully you can tell this is pretty straightforward. Just making sure you understand what the notation means, honestly. So 1 plus 3 is 4. Let's go forward and see if it gets much more difficult with this. So here 6n is a multiplication problem, right? B equals 6n. If n is 2, then really what you're saying is 6 times 2. Because they're right next to each other, so 12. So I don't feel like these get that much more difficult. Oh, here we go. Let's look at this. Jason types 18 words per minute. Let M represent the number of minutes Jason types, and W represent the total number of words he types. So the function W equals 18M is literally, if you're saying that W is number of words and M is number of minutes he types, then the number of words is equal to 18 times the number of minutes he types. That's what this says. So the number of words that he's able to type out is equal to 18 times the number of minutes that he's working on. So it's the same idea though. If M equals 10 minutes, then really you're saying 18 times 10. So he's able to type 180 words. Okay, we're up to 75 on my side. Looks like they're making the functions a little bit bigger with numbers that are larger, but really the same idea, right? 18 times M minus 13. So you'd plug in a 6 here. So C equals 18 M minus 13. M equals 6. So 18 times 6 minus 13. 60 plus 48, 108 minus 13. Okay. Okay. Hopefully I did that right. Let's see. We can check right now. Yeah. All right. If we move on to that last one, so this is the only topic I would say that's a little different than the rest, more of a preview of what we're doing next week, but it is also still a review of stuff you've done in the past. So this is IXL Topic 6AV, and this is finding a rate of change from a table. So if you're looking at this table here, you're really comparing the Y amount over the X amount. What you're really doing is you're checking for the change in Y over the change in X. And so in our situation, X and Y is represented here with days and here with amount spent. So if I go down that table, Sunday, but let's read the question before I start writing stuff in, because here it says, what's the rate of change between Tuesday and Thursday? So let's not worry about Sunday. Let's look at Tuesday and Thursday, because really I'm just comparing those two things. So this is 1 for Tuesday and 9 for Thursday. So you're literally checking how much does the Y side change? This changes by going up 8, right? 1 plus 8 is what gives me 9. And this side goes up by 2 days, right? So you're really saying $8 on top, the Y's on top, every 2 days. So I'm putting the change in Y over the change in X in a fraction. And this is what creates my rate of change, that idea of something per something. So it's $8 per 2 days, which I can reduce down to 4 over 1, right? So that's $4 every 1 day, which that's what's asking for here. How many dollars per day? So this one's probably the most challenging as far as just having to think about it. So if I'm looking at 2013 to 2015, right? So 1929, then the change in Y is plus 10. And the change in X, right, is plus 2. So if I'm paying attention to my units, this was games and this was year. So I'm saying 10 games if I do the change in Y every 2 years. Really means 5 games every 1 year. So you might have wondered why I wrote this little symbol here. That's a Greek delta, it's called, and it means change in math. So this means the change in Y over the change in X. So 5. So really it's the same idea all the way down. So I'm just going to keep doing those types of problems and paying attention to the 2 things they asked for. So 2008 to 2009. So 67, 72, right? So I'm going up here by 5. So this is 5 kilograms, if it's based on these units here of weight for a dog. And then it goes up by 1 year. So if I put this together in my fraction, it's 5 kilograms per year. Let's jump forward and see. So basically it stays the same. So again, they're just asking like May to August here. So you'd be looking at 638 to 655, which is going to go up, you know, by a certain amount, 17. But it's still that same idea. And then how many months there are between May and August. Okay, I think that's enough information to get you going. Have a nice day.